This is edition 1 of the Blacksmithing Technique Sessions. It's the Miner's Candlestick with Mark Aspery, module number 1. The Blacksmithing Technique Sessions are an audio-visual interview with a blacksmith talking through their method of making a featured forged metal piece while viewing step-by-step photos of their techniques. The following sequence is an audio-visual interview with Mark Aspery and Victoria Patti talking through Mark's personal method of making the Miner's Candlestick. There are 4 modules all together in edition number 1, and this is module number 1 and its contents. An introduction to Mark and his fondness for the Miner's Candlestick, measuring out the original stock, shouldering and drawing out the spike, drawing over the bick, removing corners, and hot cutting. A special thank you to Mark Aspery and his devotion in cultivating the craft of blacksmithing through his many endeavors. All photo credits go to Mark Aspery. He took them all. And a thank you to the first edition sponsor, the Artist Blacksmith Association of North America, otherwise known as ABANA, the nonprofit organization dedicated to preserving the craft of blacksmithing. Welcome to BlacksmitHer Radio Technique Sessions. Today we have Mark Aspery, and he will be demonstrating or talking about the Miner's Candlestick technique that he came up with. Hi Mark, how's it going?
It's going very well for me, thank you, Victoria.
Okay. Let's go to the next slide and we'll talk about the intro about the Miner's Candlestick. Go ahead and tell us a little bit about how did you start making miner candlesticks and why did you become interested in them?
I was working at the Littleton Historical Museum in South Denver there, and it was a first-person interpretive, and supposedly I was a blacksmith for the mining industry and for agriculture, and this was something synonymous of the mining industry, the miner's candlestick. And so I started to try to make these, and it was quite frustrating at first. I didn't know what I was doing, and so over trial and error I got somewhere along the road, and I saw Francis Whitaker make one. He had a different technique to mine, but I rather liked the way he'd done it, or approached it, his mental attitude really. And so I came back to mine. I didn't use Francis's techniques, but certainly his input had a lot of influence into the way I did it. And so I started my journey with the Miner's Candlestick. And there's tons of these things out, hundreds of different designs, from just pieces of wrapped wire to silver inlay, you know, for mine supervisors, etc.
And then some of them were, engraved with their names as well? Yeah. And then some pieces, if you look at the eye, there were some pieces with a pick or a hammer actually put inside of the eye there. So definitely ornamental and not functional. And how many different techniques have you actually observed?
So some of them are just like a high steel wire wrapped, so it's literally just like a coil spring. Some are very crude. Some were produced. I think the last patent for these things was 1915 or so, so quite recent in the mining industry. And here's the juxtaposition. There was a safety lamp in the UK invented in 1815, 100 years prior. And so it basically covered a naked flame with a mesh. And the mesh would allow gas to get in and would ignite within the naked flame. But we know that you can't pass a flame through a gauze. And so it would supposedly prevent explosions. And this was the Davies safety lamp. So it seems funny to me that we have a safety lamp invented 100 years prior to some of the last patents of the miner's candlestick, which is very crude and very dangerous because you've got a naked flame in a gas pit.
Right.
It seems a little odd, and especially when you think that a lot of the miners that came over here to mine in the western mines came from Europe, where the Davies safety lamp was in use.
Oh, really? So
yeah. And these miners' candlesticks, I mean, they're infamous. They've burnt down mines. They've been used in murders. They're all sorts of things. You know, they're very much American West history. I forget where they're invented, but they were certainly used in the hard rock mines of Nevada. So they're very much Western American mining history.
Now, I know that they're also known as the Sticking Tommy, and I tried to do a little research yesterday on how that name came about, and I couldn't find anything. Do you know?
I haven't a clue.
Yeah.
No, I mean, Tommy, I'm thinking, is referring to British, and they called us Tommies in the First World War. I don't know if that's anything to do with it.
Okay. Let's talk a little bit about how you're going to begin with this technique.
Well, the first thing for me is that we're making this out of one piece, which is not necessarily the way it could be done. You could make this out of multiple pieces. Certainly the candle holder could be a separate piece of sheet brazed on. The hook could be added as a forge weld or a mortise and tenon, anything like that. And so for me, I wanted to try and make it out of one piece. It's the games that we play, and this was the game that I wanted to play. So I took a length of 3/4 inch by 1/4 inch flat bar, and I marked it out. And typically I mark it out at about 1 inch, 3 inches, about 7 1/4 inches, and then the last mark is at about 9 inches or so. And that gives me enough material to make one candlestick.
The whole process is so interesting, and I would personally be worried of burning it up because it really is only 1/4 by 3/4. Does that happen?
That's right. Well, it gets down to 1/4 inch square at one stage, and then 16th. So again, it comes down to these games that we play with ourselves, because the customer, I expect in this particular case, the customer would care. But it was a skills challenge for me, and certainly I learned a lot while I was doing this. It improved my skills a lot, and so I enjoyed this technique for a number of reasons. One, it was an authentic piece, and two, it really taught me a lot.
Now, let's talk about the techniques themselves and how much skill you will need. So is this for a pretty experienced and skilled blacksmith to perform?
No, I don't think so. These are basic skills. Again, I'm not a big believer that we have a lot of advanced blacksmithing. These are basic skills: drawing down, laying off, isolating material, manipulating the material. I've added a couple of curveballs with the upset corners, but they don't have to be there. It's just general good blacksmithing work. Just happens to be all in one piece, all from the same bar.
Okay, and how long does it take you to make one of these?
Oh, less than an hour. I can do it as a demo probably in an hour and a half. You know, that's with dialogue, etc. So I'm thinking probably about 30 or 40 minutes.
And how many of these have you made?
Not that many. You know, I couldn't give you a number. I make a few, I learn something, and something else comes up and I put them down. You know, I don't really have a market for them.
Yeah. But just in general, you know, so that inexperienced smiths, such as me, would know that, okay, Mark's made maybe 20 of these, and he's probably got it down to an hour and a half or an hour, where it might take me 5 hours.
Right, and that's typical. So if I teach a particular subject, any subject, I normally find that it's a 1 to 4 ratio. If it takes me an hour, it's going to take the student 4 hours.
Oh, great. Oh, that's good to know that that's typical. That's very good. Oh, excellent. Okay. All right. Great. Well, let's just start right into the first step. All right, let's go ahead and talk about the first step. What are we doing here?
We're using a half-face blow to shoulder in at the 1 inch mark. This, the material we're drawing out is actually going to be the spike on the end of this sticking tommy or candlestick. So I want you to draw it down to less than half the thickness remaining. Don't just take it down to 3/8 of an inch. Go less than that.
Okay.
And then you'll be ready for the splitting.
Why less?
If we go less, then the shoulder of the bit that we're forging out won't interfere with the chamfer of the chisel when you're trying to place the chisel a little later. Okay. And we know we're going to draw this down to a tapered spike anyway at some later stage. So why not do that now and get rid of the possibility of that frustration with the chisel?
Sure. Okay. And here?
We're just drawing out the bit that we just set down over the bick a little bit. We have that material, so let's just draw it down a little bit, get it out the way. And this is going to help the bar lay flat on the anvil. At the 3-inch mark, and now we're on the offside edge of the anvil, we're going to do the same thing again. We're going to create a shoulder. Again, take it down to 5/16 or so. Don't go too far this stage, because we've got a little cleanup around that area that we need to deal with a little later. And you can see I've got a slight taper there, which is purposeful. And I'm going to come back just underneath where the hammer is now and then go to work with the bick in the next step or so. Mm-hmm. All I'm trying to do is just draw the material out. But this is the important thing. Do not correct for any growth in width at this stage. It's tempting to just turn it on its side and correct for the growth. But we're going to need that to make my fancy square corners, or upset corners anyway.
Okay. And that growth, you mean on this flat side here?
That's right, exactly
where
you're pointing. Yes,
leave
it alone.
Bulged out. Okay. And here's the bick action.
That's right. So we're just going to set it down. And the reason I like the bick is because that transition from the bick material into the parent stock, the unforged parent stock, is a curve, which means at some stage, if you want to come in and create a shoulder on there, which we will do at some stage, then you don't run the risk of creating a cold shut. If I did that move over the near side edge of the anvil and had what I would call a set transition that looks like it's been put there by a set hammer, then I would have a hard shoulder, and if I try to extend it, I run the risk of creating a cold shut. It would just fold, collapse.
Okay.
And this one gives you a little bit more safety.
And this curve, that's what your main goal is here.
That's right.
Okay. And the next step is showing...
I'm just taking the middle bit out of that. What I need is parallel stock, or stock equal in width, as you say. And I need to be able to clamp this in my vise to help lower or draw down the hook. So this needs to fit in the vise. So I just need something I can grip in the vise that's not going to spin, therefore parallel.
And how far down do you draw this?
Just take it down to equal in thickness to our first shoulder. The one, that's right, exactly. Just there on the left.
Okay.
So we have a nice parallel section. And we should be looking at something that's 5/16 or so of an inch thick at this stage.
We're removing the corner on this now.
And this is important. So any time that you are going to lift a piece of bar up, you're going to have a compression of that outside edge. So let's talk about dragons and wizards and things like this. You know, you've got horns of a dragon that people will sometimes cut from the neck going towards the head, and then they want to lift it up. Well, unless you have space for that root to move into, it's just going to pucker. And create cold shuts. And so all I'm doing is just knocking the excess material away, which is, I suppose, a slight upsetting process as well as, so that when I lift up the bit that's going to make the hook, I'm not going to get puckering of the material.
Now, this corner, you have already...
Yes. That's what we're doing. We're removing that corner.
Removed it. And it used to look like this because that's
right.
what you shouldered off before.
Yes, exactly.
Okay. Oh, now we're going to the hot cut.
That's right. And you can see I'm cutting now from the end. You can see the chamfer of the chisel has got room to move. That's why we drew down the first shoulder down to about 5/16, and I'm cutting back. You'll notice the two arrows on the bottom. I want you to cut very close to the equal in thickness of the bit that you are cutting apart. So this is 3/4. We're cutting it in half. That's going to leave you, let's call it 3/8. So I want you to take that to a fat 3/8. I think I'm going to call it 7/16. If you leave too much, you're going to have to work it really hard to draw it down later. If you leave too little, you run the risk of it looking weedy or breaking off.
Breaking off, right.
Yeah.
Okay, so this is about 7/16 maybe.
Yeah, thereabouts.
And that's kind of equaling this, the width of this.
That's right. Exactly, yes.
And this is the shoulder that we just removed.
Right. Yeah.
Okay.
So you can see I can now stand up that hook material, the top material, without the outside edge, the material that we just removed, getting in the way now.
All right. Next slide is you showing just finishing the cut over...
That's right. Now, with my fancy little chisel here, I have 3 edges on my chisel. The bit that's actually in the material now is the sharp. And then if you look at the left-hand edge of the slide of the chisel, that's an edge too. And the right-hand side is a half round. So I'm actually got the half round.
This is the hard edge, and this is the half round.
That's right. So I'm trying to create a soft edge in the material because we're going to open this material. And if I have a hard edge, as you call it, a sharp edge, we possibly will propagate a crack.
Right.
We're going to deal with this anyway, but it's just a nice habit to get into.
Nice. Okay.
I think we used to deal with this, with wrought iron. We'd punch a hole or drill a hole and then cut to the drilled hole. Mm-hmm. Do you remember seeing those diagrams?
Mm-hmm. Mm-hmm.
Yeah.
Did you make this chisel?
Yes.
Okay. All right. Now, when you're hot cutting, you're going to have a little bit of a rasp, like leftover bits.
Yes, you are. Now, again, this tool has to go out of the door. A miner buys this tool. It's not typically bought by the company. So it has to go out the door for a miner's pocketbook, cheap, basically. Mm-hmm. And so I don't want to spend a lot of time messing around. So I'm actually going to rely on the oxidization in the fire to remove that rag. I'm not going to try and wipe that with a rasp. But that means I'm cutting it hot. So it will actually cut through, leave a small amount of rag, as opposed to cutting it kind of lukewarm, let's say a dull red, where it will tear and you'll have a lot more rag.
Right. Oh, okay. And this here is the sacrificial plate that you have on top of your anvil face so that you're not defacing the face of your anvil with your hot cut.
That's right, or damaging my hut cut. I typically use my hut cuts, so they're pretty soft anyway.
Right, okay. Do you temper your chisels, your hot cuts?
I do, and I know that a reasonable person would say, why bother, because you're putting it into hot steel. Mm-hmm. And I agree with the question. So I conducted a test, and I made 2 tools of equal material, if you like. I cut them from the same bar. I made them at the same time. One I heat treated, as I usually do. One I left as forged. And the heat treated one, even though it was abused and I pulled color on it, etc., lasted much longer. It was significantly longer.
Wow. Interesting.
So,
and yes, when you are hot cutting, let's say you make a line and go halfway through the material, and then you cool this, right?
Yes, I do. Now, I typically will work that chisel, even though it's been messed up and the heat treatment's been messed up, it will work in hot steel. So I'm less apt to cool my chisel. I'm very apt to cool my punches because they will mushroom on the end. But that chisel seems to work just fine. I'll just probably go from start to finish without chilling that. It would be more correct. If I did chill it, I would understand that, but I probably would not.
And is this done in one heat? Or a couple?
Yes, it is. Yeah, one heat. Again, this has to go out the door for a certain amount of money. Now, as you first start, you might do it in 2 heats.
Right.
Fine, I understand that. But your goal is to try and get this, let's be efficient.
Right.
And that's where this learning process of using this as a teaching tool as opposed to just making candlesticks starts to become important.
Okay, great. Next slide. We're talking about...
Now, we forged in the corner, the offending corner, but as your little arrow shows there, we could also cut it off. I have not enjoyed great success cutting it off. Tends to be that the chisel slips away because there's not such a lot of material there to hold the chisel, so you end up with a chamfer. So, yes, you can do it. Maybe in theory you can do it. In practice, I've not enjoyed great results.
But we've already removed that corner.
That's right. But if you've forgotten about it,
oh, okay,
as is easily done, you can come back. Because if you forge that in now, you're just going to close up the cut. And so you're starting to get a problem. That will propagate a crack. So if you've forgotten about it and you need to get out of jail free, there it is.
And this is the time to correct it now.
Now is the time to correct it because we're going to open up that hook material in our next step, I think.
BlacksmitHer Radio, forging blacksmiths together.